Alright, so in this video we are going to learn how to do some more complicated conversions, two-step conversions. So we're going to go from, say, a number of particles to a number of moles and then to a number of grams, or a number of particles to a number of moles to liters. So your conversions will require two-step calculation. Right, so you've already done the following conversions. You've already learned how to convert between number of items and moles and back, or between grams and moles, or volumes and moles. And so what you notice here is that the big main common factor on all of these conversions are moles. Alright, so I've drawn a little mole map here to kind of help us get or navigate some of these calculations that we're going to be making. So if you are trying to convert between, say, particles, which could be atoms, molecules, or formula units, and moles, what you're going to need is you're going to need to either multiply or you're going to need to divide by 6.022 times 10 to the 23rd. If you are going between moles and grams, you're going to need to either multiply or divide by the molar mass of whatever the substance is that we're trying to determine the moles or the grams of. And if you're trying to get between moles and liters, this is only, of course, for gases at STP. We learned in the last video you're going to need to either multiply or divide by 22.4 liters. So if I want to convert a number of grams to, say, a number of liters, notice I have to go through moles first. Or if I want to convert particles to a number of grams, I have to go through moles first. There is no direct conversion. So let's set up a little example of how we're going to go about making these calculations. So the question is, how many molecules are in 24 grams of water? So the first thing I'm going to identify is what is it that I'm given. So this is my given. And of course, what they're asking me to find, what I want to convert to, is a number of molecules. So I'm given a mass in grams, and I'm asked to go to molecules, which is a particle number. So I've got to convert to moles and then to particles. So here's the plan. We're going to go from grams to moles, so grams to moles, and then moles to molecules, moles to molecules. So that'll be two conversions. So in those two conversions, the first one you're going to go from grams to moles. And to get from grams to moles, you're going to need the molar mass of the substance. So to get from grams to moles, you're going to need the molar mass. And then once you're in moles, once you've converted to moles, to get from moles to particles or moles to molecules, you're going to need this ratio, that 1 mole is equal to 6.022 times 10 to the 23rd particles. So I'm going to go ahead and do these two conversions, and I'm going to do them in one big long equation. So our plan is to go from grams to moles to molecules. So as with anything, remember my template. You're going to start with what you were given, and you're going to convert it to the units that you want by multiplying by a ratio of a conversion factor that has the units you want on top and the units of the given on the bottom. So let's do that for this problem. We've got 24 grams of water. And we want to multiply it by a ratio where grams of water are on the bottom and moles on the top, because our first step is we're going to go from grams to moles. Remember, grams to moles. So that's molar mass. The molar mass of water is 18.015 grams per mole. Okay, so instead of making this calculation and getting an answer right here, so instead of doing something like this, what I'm going to do is I'm going to go ahead and set up the second part of my calculation. So I'm going to multiply by a second ratio that gets rid of the units that I want on my first step to the units that I want in my final step. So ultimately, the units that I'm looking for from the original question, which is I want molecules. This isn't going to get me to molecules. This is only going to get me, of course, to moles. And I don't want to be just in moles. So I'm going to multiply. This is the second half, or the second part. I'm going to try to put moles on the bottom, or I'm going to put moles on the bottom, and then molecules on the top. And I'm going to fill in the 6.022 times 10 to the 23rd molecules per mole. So my grams unit will cancel, my moles unit will cancel, and I'll be left with molecules. So I end up multiplying 2 by 6.022 times 10 to the 23rd over 18.015 times 1. And of course, molecules is what doesn't cancel. So if I work this out in my calculator, I get 8.02 times 10 to the 23rd molecules. So I was able to convert from grams to molecules all in one big equation. This process of setting up an equation where you are converting one unit to another unit actually has a name. It's called dimensional analysis. You'll hear me refer to it as dimensional analysis, or sometimes factor label method. And it's just a fancy mathy word or process for converting units from one to another. Let's do another example. The question says, how many liters of CH4 gas is in 162 grams of CH4 at STP? So identify your given. Your given is that you have 162 grams of CH4. And what you were asked to find, what you're wanting to get, are a number of liters. So we want to go from a mass in grams to a liters or a volume. So we are going to make two conversions, going from grams to moles and then moles to liters. All right, so how are we going to do that? So there will be two conversions that will be made here. The first conversion from grams to moles, we're going to need the molar mass of CH4 for that one. And then once we have moles and we want to turn it into liters, we're going to need this ratio where 1 mole of any gas at STP equals 22.4 liters of that gas. So as always, we should start with what we were given, which is 162 grams of CH4. And to make that first conversion using molar mass, we know we want to get to moles from grams, and we know we can calculate the molar mass of CH4. That's 16.043 grams. So that'll get rid of grams and leave us with moles. Now we can take that number of moles and convert it to liters using this ratio. So we know that a mole of any gas at STP can occupy 22.4 liters. So we can cross out the moles, and ultimately we'll end up with what we were asked to find, which is liters. So if we do the math, we're going to end up taking 162, multiplying it by 22.4, and dividing by 16.043. So you can leave the ones out because the ones, just anything multiplied or divided by 1, you know, is itself. And the answer we get is 226 liters of CH4 gas. So in any of these conversions, the key is planning your conversion. So if I want to go from, say, particles to liters, I know that I'm going to need to take that number of particles and convert it to moles first, and then moles to liters. Or if I want to go, say, particles to grams, I would need to convert particles to moles and moles to grams. So it's really important that you think through how you're going to go through these conversions and plan them out before you start to make them. So why don't you try to do one on your own? Here's the question. How much would 3.2 times 10 to the 24th atoms of copper weigh? So pause the video and work through it, and then unpause and see if you did it correctly. All right, so let's look at the plan first. So here's what you're given, and here's what you're trying to find, which is a weight. And weight is equal to mass in grams. So the plan is we're going to go from atoms to moles, and then moles to a final mass. So the first step will be taking atoms to moles using this ratio, and then moles to grams using the molar mass. So here's what the setup would look like. We're going to start with our given, and then we're going to multiply by the ratio 1 mole over 6.022 times 10 to the 23rd atoms, so that atoms cancels. And then we're going to multiply by another ratio with the molar mass of copper, grams on top and moles on the bottom, so that ultimately we're left with grams of copper. So your answer should be about 338 grams of copper. So that's how much this many atoms of copper should weigh. And that brings us to the end of this tutorial on how to make some two-step conversions in chemistry.